Our next speaker is Vijay Reddy, and he's going to do some of his own introduction. I will just say that he is the head of AI services at Google. Very exciting. And we're excited to hear what this practical engineer has to tell us. Thank you, Vijay.
Testing, testing. Okay, hey everyone. Nice to be here. So, as I was introduced, my name is Vijay, head of AI services for not all of Google. That was a generous introduction though, but for Google Cloud Platform for the East region and for Latin America. And what head of AI services means is that I lead a team of AI consultants and AI engineers, and we implement AI solutions leveraging the Google Cloud Platform for enterprise customers. And in particular, we focus on implementing solutions for customers that meet 3 criteria. So the first being that there's a high level of customization required. So we're not building cats versus dogs here. It's not anything that can be done with an AutoML model or an API. Things that require a high level of customization, our team typically gets brought in for. Number 2, things that drive a high level of business value, and that's just basic economics. Our services are pretty expensive, and so the customer needs to justify a high ROI to engage with us. And the third, which is going to be part of the theme of this talk, is we focus on getting things into production. And there's 2 basic reasons for that. The first is there's no ROI for a business until something is in production, pretty obvious. And the second is we learn from experience. We didn't used to help our customers put things into production. We more concerned ourselves with the model prototyping, the model development, and then handed it off to the customer to then put these things into production on their own. But what we found out is a lot of times that didn't happen. And the reason why that didn't happen, or at least my theory of why that didn't happen, is because the skill set required to develop models is very different from the skill set required to productionalize models. So someone who's good at developing models, what are the attributes of that person? Well, they're good at doing research. You have to survey the state of the art. You have to see what are the current approaches people use for this problem. They have to do a lot of experimentation. There's creativity involved. There's leaps of intuition. It's definitely part art, part science. Whereas the productionizing of this is requires really mature software engineering skills. You're building production grade pipelines after all. It also requires a real close understanding of how this solution is going to be used by the business. Who is the end user? What are their requirements for monitoring, for interpretability? And I would argue maturity of the latter, which we could call under the umbrella of MLOps, maturity for that lags behind the maturity of the discipline of developing models. And that's in large part because the proliferation of data science, we can say, happened over the last 10 years. We went from companies that you just had a handful of really tech-savvy companies that had data scientists 10 years ago, to now we have basically any company above a certain size with information is required to have data scientists. And that wave came out of academia, right? It came from the resurgence of deep learning, the Jeff Hintons, the Jan LeCuns of the world. And in academia, priorities are very different. So Khalife hinted at this at the lunch panel where he's talking about, I didn't know this, but there was an entire team of data scientists that got fired because they were just working on cool research projects and it wasn't anything that the business cared about. And that's natural because in academia, not all the time, but a lot of the time, what you care about is moving the state of the art forward, and the state of the art is measured by model metrics. And so moving the needle from 0.85 PRAUC to 0.9 PRAUC on some use case can make a career. and these are the people that are educating the next generation of data scientists, and so they're going to be biased towards educating them on how to move the needle from 0.85 PRAUC to 0.9 PRAUC. So you can see where I'm going with this. When this generation of data scientists enters industry, there's a disconnect. Their boss does not even know what PRAUC is. If they're lucky, their boss might, but certainly their boss's boss's boss doesn't know what PRAUC is. What that person cares about is building something into production that is going to increase revenue, streamline operations, or in some other way impact the core business. And what ends up happening is you have data scientists being asked to do things in which they have little or no actual training. Luckily, data scientists are a smart bunch, so they figure things out on the fly, but they make mistakes along the way. They learn from those mistakes, and along the way, the discipline of MLOps is created. So the goal of this talk is I've made a lot of these mistakes. I've witnessed these mistakes that happen when you transition into the practical side of getting things into production. And hopefully some of you can benefit from this wisdom so you don't have to learn it the hard way. And maybe not repeat some of these mistakes I'm going to talk about. So I'm going to talk about 4 in particular. Some of these are mistakes I've made personally. Some of these are mistakes that I've witnessed. And the first one is maintainability trumps performance. So several years back, I was tasked with migrating a solution that detected damage from cars that had been in accidents. This was for a car insurance company, so that they could appraise what the approximate repair cost would be. So this solution was already built by another team. My team's task was to migrate the solution to a GCP native tech stack. And one of the selling points of this solution was that it involved 25 machine learning models. And people get excited when they hear 25 models, because not everybody outside of our field understands how models work, but everybody knows how to count. And so the sales folks will say, oh, it has 25 models, and they'll put that in the deck. And then the customers will get really excited and say, oh, 25, yeah, that must be better than 20, clearly. And I'm kind of poking fun of it, but even in our industry, I see this line of thinking in which we wear complexity as a badge of honor. How many of you saw the opening talk from Joel Gruz on simplicity? Okay, I did not have a chance to see that, but I know the name of it was simplicity, so I would argue that, or I would think he's talking about some similar concepts. And so what happens with this complexity is, while it may sell things, in practice it's a bit of a nightmare. Right? It made this system really expensive to retrain. It made the system really hard to debug because you don't know which of these 25 models is contributing to an error. And just in general, it made the system really hard to maintain. And the cautionary tale is this customer eventually abandoned the solution altogether in favor of a full service vendor where they just didn't have to deal with any of that. And in hindsight, we probably could have delivered a solution with comparable performance, maybe slightly less, with a fraction of the number of models. But the team was not thinking about maintainability at the time that they were developing the solution. They were just trying to squeeze every ounce of precision and recall and saying, oh, can we make a purpose-built model for this subset of the problem? And yes, they ended up with a system that was very performant, but in practice, it was unmaintainable. So the lesson here is, when you're developing these solutions, put yourself in the shoes of the person who is eventually going to have to maintain it. Go a step farther and understand the skill sets of the team that is going to be tasked with maintaining it, and make sure you're developing with that in mind. Because if you don't, all of your hard work is going to be for naught, because eventually the customer is not going to be able to maintain it. This is a this is a quote that many of you have probably seen, but it gets the same thing. Is we should celebrating simplicity, right? I would have written a shorter letter, but I did not have the time. It takes a lot of time and thought to trim all the fat out of a solution and think about what is really the essential parts that are really needed and only keep those parts. Okay, any Office Space fans in here? This is my favorite movie of all time. And so the second practical tip that I have for you all is focus on the metrics that matter to your boss's boss. So this is the guy who doesn't understand what PRAUC is, or the girl who doesn't understand what PRAUC is, nor should they have to. So we'll go back to this previous car insurance use case that I was talking about. And the team that built this, the metrics they were focused on were precision and recall of the various car parts, the front bumper, quarter panel, etc. And those are perfectly reasonable choices for metrics to measure the efficacy of those models. The problem is that doing well on those metrics in and of itself has nothing to do with ROI for the customer. So who here has ever had to file a car insurance claim? Okay, about half. I myself have been lucky enough not to have had to do that, but from what I understand, it can be quite a painful, frustrating process. And from what I know from working with this customer is on the customer side, it's also an expensive process to process these claims. You have to have humans appraise and look at images and try to estimate the cost of damage, and is it worth even trying to repair this, or should we just total it and give the customer back the fair market value of the car? And so what the business really cared about in this case was shortening time to appraisal. The time to process a claim, if it took an hour today and we got that down to 50 minutes, that was what the business actually cared about. And when you think about it in those terms, now you have to think about a whole set of other things other than precision and recall. You have to ask, how does the customer do this today? Or if you're part of the business, how do we do this today? You have to ask, how can I surface the outputs of my model in a way that would be useful to the people that are doing this today and reduce the time that they're taking to do it? You have to ask, what do I need to do to make the end users trust this system? What are their interpretability and explainability requirements? What are their monitoring requirements? And when we got involved with the project, we started steering the ship in this direction, where we were focusing really on reducing time to claim instead of just precision and recall. But by that point, a lot of the damage had already been done, that in addition to the fact that there was 25 models and it was too complex to maintain. And so we eventually lost the business. So you can save yourself from making this mistake. In the beginning, focus on the metrics that matter to your boss's boss. I'll give you a second to read this comic. So invest in feedback loops. What this comic is getting at is there's often a trade-off between putting more effort up front to save time later versus doing the easy thing now. And we'll get back to this in a second and what this has to do with feedback loops. But again, I like doing polls. So how many people in this audience have implemented a supervised machine learning model? Okay, so maybe a little more than half. How many people have implemented a feedback loop that makes that model get smarter over time? Okay, I'm seeing maybe 9 hands. So a fraction. And there's a lot of reasons why we don't build feedback loops. They require a lot of investment up front. They're not required to launch a product. And in fact, they don't make the product any better at launch. It's not for maybe a year down the road where you've collected data that you get any payback in that, on that ROI. So when we're working within the constraints of a corporate world where you have timeline pressure, where you have fixed budgets, it's really hard to make the case that we should invest all this time in this plumbing to create this feedback loop for something that isn't even required for launch. And as a result, it usually doesn't happen. So what I would like to do is make the case, or help you make the case of why you should invest this time up front. So for those of you, a little bit more than half of you have built supervised machine learning models, you know the single most important indicator of success is the quality of your data. Do the appropriate signals reside in your feature set? Do you have the appropriate labels mapped to those signals? And if you've ever had an unlabeled set that you then have to go and procure labels for, you know that that's a painful process, it's a slow process, it's an expensive process. And so that is why feedback loops are so invaluable, and by the time you need them, it's too late. So number one, you can get labels for free a lot of the time. So going back to our car insurance example, the appraiser is already identifying the damaged parts of the car in a report. They're doing this today. So all we need to do is build the feedback mechanism to capture that instead of manually labeling things. Number two, the label quality will often be better when it's done in a feedback loop because the feedback is coming directly from the end user. So this does not apply always if you're doing something like cats versus dogs. There's no domain expertise required. But in this example, where you're dealing with very specific parts of cars like left rear quarter panel top molding. This is something the average person doesn't even know that's the name of a car part. And so if you're using a crowdsourced labeling service, you're going to have labeling quality issues. And what's even more insidious about that is when you have issues, if something is consistently mislabeled across your training sets and your test set, you're not even going to realize that there's an issue because your model metrics are going to look good. It's going to be after you launch in production when the end user points out that something doesn't look right that you're going to find out that you had an issue with some of this label quality. The third reason is it will allow you to find and proactively react to your blind spots. So the beauty of feedback loops is you have side by side what the model predicted and the ground truth that the end user is providing. And you can make all kinds of reports, break it down by type of car, by class. And if there's any patterns or blind spots in the model, those will quickly become apparent, and you can proactively and very surgically target that problem. And end users are forgiving to a point, but if you don't provide them a mechanism to let you know when something's wrong, and you don't act on that feedback in the form of retraining, you're going to lose the trust of your users. And what's going to end up happening is this product that you invested a bunch of time in is going to have 15 minutes of fame in production, and then you're going to lose adoption. And again, all your work is going to be for naught. So we want to avoid that. Whenever you have the opportunity to, fight for the investment to make that feedback loop up front. Your future self will thank you that you did. Okay. And the last tip I have for you is try the hammer first. Even if you have the fanciest nail gun in the world, that doesn't mean you should throw out all the hammers in your house. And as data scientists, we have access to some pretty powerful, cool tools, arguably the most powerful being deep learning. And when we have fancy tools, we want to use them. So a couple of years back, a colleague and I were building a document AI system. And as part of this, among other things, we had to extract dates and times and days of weeks from unstructured text. And so we said, oh, this is a classic NLP entity extraction problem. we have a no-code AutoML product that actually does NLP entity extraction. So we'll just label some data, we'll train the model, boom, done. But in this particular project, we were actually ahead of schedule, which rarely happens, but it was the case. So we had a little bit more time to experiment and play with. So I said, just as an experiment, you go ahead and build the NLP entity extraction model, and I'm just going to see what I can do with regular expressions. And so my colleague went off and built a data pipeline to extract sentences from the source text. He then went through the process of manually labeling each of those sentences with the date entities and the time entities and the days of weeks entities. And he probably spent 6 hours labeling, got 200 sentences. Then he got to a point where he felt, okay, I can throw this into the AutoML model, train it. And then in parallel, I'm doing my approach. And we did this properly, where we had a holdout test data set that neither of us were going to see until we came back and compared results. And to my surprise, within 30 minutes, I had written 5 regular expressions that had extracted everything that I wanted from the training set. And so we came back the next week and we compared it on the test data set. And this wasn't that difficult of a problem. So both of our solutions had 100% recall. But the deep learning solution was actually overgeneralizing. So it had some false positives, and it was thinking some things were dates that weren't actually dates. Whereas the regular expression solution also had 100% precision. And yes, we could have gone back and modified the deep learning approach and dealt with that overgeneralization problem. But the point is that we already had a solution that took me 30 minutes and was an order of magnitude cheaper and faster to run that we probably wouldn't have even thought to try unless we had this extra time built into the project schedule. So don't throw out your hammers. I know data scientists cringed whenever we say do rules-based anything. We're very indoctrinated into rules-based it's bad and it's hard to maintain and it's ugly. But there are still use cases in which a simple hammer makes a lot more sense than using a power tool. So those are the tips that I have for you. I hope at least one of these practical lessons will save you from having to learn the same thing the hard way. And yeah, that's all I have. I'll take questions if we have a couple extra minutes, if anyone has them.
Yeah, we do. We have a couple of minutes. Any questions? Yeah, right up front. I'm coming. Here you go, Ruben.
Hi there, interesting talk. Brought back a lot of bad memories for me too, because I was a consultant in the cloud for 3.5 years, so a lot of stories there. But what does that feedback loop mechanism look like in production? Can you give an example of what that looks like from the developer side or the engineering side, and then what does it look like from the customer's perspective?
Yeah, so you've given me an opportunity to make a product plug, which is there's actually something within the Google Cloud Vertex AI platform called continuous evaluation. And this is the purpose of it. And what you do is you specify a percentage of the predictions that are made, because normally it's too expensive to go and relabel all of the predictions, but you could say for 1% of the predictions that are made each day, you specify a labeling source, and that could be the end user, or you could also send it back to a crowd labeling service. And so basically, over time, you're continually getting feedback about how do the human ground truths compared to your predictions. Now, if you want to do what I mentioned about getting labels for free, where the end user is actually already doing this, then there's some more UI work that you have to do. There's not a simple product that is going to implement that for you. So you would have to do some plumbing between the UI that the end user is entering their ground truth into, and then a data pipeline to get it back into the schema of your training data set. So that would be more custom.
One more? Yes.
Do you think increasing the pipeline for the clickstream, getting the feedback is a form of feedback loop?
Can you repeat his question, please?
We basically increase the pipeline. We collect more clickstream data from the job-seeker. And do you think the clickstream data, it's a form of feedback loop?
So if the clickstream data is what you're considering your ground truth signal, which a lot of times it is, that you're optimizing for click-through rate, then yes, that is a feedback loop. That's often the only time you can really evaluate recommendation systems. For example, you have your offline metrics, but what really matters is when you put it online, does the click-through rate actually increase as a result of having implemented this system? So yeah, that's the system, or that's a scenario in which you kind of get this feedback loop pretty naturally.
Very nice. We don't have more time for questions, but thank you so much.
My pleasure.